Hey everybody, today we will discuss some trigonometric applications, and we'll start with what we call the law of sines. What the law of sines allows us to do, it allows us to explore using trigonometry beyond the right triangle. See, SOHCAHTOA that we've used in the past strictly can only be used in a right triangle, where the law of sines can be used in any triangle. First, to understand the parts that belong here, if we draw a triangle, let's call this a triangle, and I'll refer to it as triangle ABC. Notice that angles are typically written with capital letters, and the sides can be written with lowercase letters. So the way the relationship works, and if I look at A over the sine of A, side A, which is lowercase a, is always going to be opposite its corresponding angle. So side A is opposite angle A. Side B is opposite angle B. And side C is opposite angle C. So really what the law of sines is, it's honestly a proportion comparing a pair of angles and sides. Notice that proportions usually have two equal fractions. In this case, they show three. Generally, we only use 2 out of the 3. Let me explain what I mean in this next example. So it says in triangle ABC, and I'll just draw the triangle again. So I have triangle ABC. They say angle A is 45 degrees. I'll label that. Angle B is 30 degrees, and side A is 10. So remember how that works again. Side A is opposite angle A. So side A is 10. The question's asking for what's the length of side B. All right, so again, we can't use SOHCAHTOA here. There is no hypotenuse. There is no right angle. So I'm going to use the law of sines. Now, which letters are being used in this case? I see A, I see side A, angle A. I see side B, angle B. There's no mention of C in this case. So the law of sines in this case should be A over the sine of angle A equals side B over the sine of angle B. All right, so here we go. We're just going to substitute in the values that are given to us. Side A is 10. That's going to be over the sine of angle A. Well, that's a sine of 45, right? And then B is what we want to find, and that's going to be over the sine of its angle, which is going to be 30. And now we have a proportion. So what we can do is we can cross multiply. So if I cross multiply here, you would get B sine 45 is equal to 10 sine 30. To solve for B, I'll divide by the sine of 45. We go to our calculator, and then type it. I'm going to type it in just like this, okay? I'm going to go to my calculator. I'm going to type in 10 sine 30. Again, make sure you're in degrees. 10 sine 30. Now close parentheses. Divided by the sine of 45. And this should be your length of side B. Okay? All these, if you read the directions at the top, they all say nearest tenth. So I'll say B is equal to about 7.1. All right? So that's how the law of sines works. Let's look at another example. Now, they didn't mention in this case specific A's, B's, and C's. In this case, actually, we have P, Q, and R. The way I kind of generalize these things is the way the law of sines works. It's always going to be the side over the sine of the angle. Okay, equals the side over the sine of the angle. So take a side that you know. Well, we know this side here is 10, isn't it? So 10 is the side over the sine of. Now, which angle is across from that? 30 degrees. Now, what do they want? They want side QR. So I'll call that X. So that's going to be the side, and now over the sine of the angle. All right, so here's our problem. We don't know the angle. We don't know the angle that's across from the X. That would be angle P, by the way. But one observation you can make is that this is an isosceles triangle. So wouldn't it be true that this angle over here is 30 as well? 30 and 30 makes 60. So therefore, the third angle in this triangle has to be 120 degrees. All right, so you might have to do a little bit of extra work on the side to figure out that missing part. All right, here we go. We're going to cross multiply. I'm going to write x sine 30 is equal to 10 sine 120. I'll divide by the sine of 30. All right, and what do we get? So I go to my calculator. We're going to do 10 sine 120 divided by sine 30. So 10 sine 120. I'm going to close the parentheses. And I'm going to divide that by the sine 30. And to the nearest tenth, we'll say that it's about 17.3. Let me just double check that. Yep, 17.3. And in this case, it would be cm. All right, so that's like the law of sines in literal finding missing values. The questions that we're going to get into now are really the trig applications part refers to doing a multi-step question. So these are the tougher questions, and the law of sines are going to help us do it. Okay, here we go. As shown in the accompanying diagram here, the ship is heading directly towards a lighthouse whose beacon is 125 feet above sea level. Okay, that's the height of the lighthouse. At the first sighting point A, the angle of elevation is 7 degrees. Okay, and a short time later, the angle of elevation is 16 degrees. So envision as you get closer to an object. You're in this boat, you see the lighthouse from far away. It will look pretty small. Well, what happens when you approach the lighthouse? The closer you get to the lighthouse, does the lighthouse look bigger or smaller? Usually it looks bigger. That's because your angle of elevation is going to increase as the object gets closer to you, okay? So what I want you to see here is that we have two triangles. Actually, there's three triangles. There's the triangle with the 16 degrees, there's the triangle with the 7 degrees, and there's the big triangle ABC. Okay? Now, what do they want? They want the distance from A to D. I will label that as X. All right, so the way these questions usually work is you have to do the work twice. All right, now, here's what I mean. I want you to first focus on the triangle that has the side given to you. That's the smaller red triangle. I'm going to use this because this triangle has the most information in it. Now, out of habit, what we like to do is we like to work from one triangle to the other. So I'm going to first deal with the red triangle, then I'm going to get something out of that, and I'm going to move into the blue triangle. And the blue triangle is going to be where the X is. All right, so again, it's almost like we're going to do this one first, we're going to do this one second. Okay? 1 and 2. So what I would tell you to do is let's find something that the two triangles there have in common. Okay? And what do the two triangles have in common? They have a side in common, don't they? That side is DB. I'm going to call that side DB, I'm going to call it Y. I'm not going to use X because X is going to be used for something else. So let's use, and I'll use the law of sines in this case if I want. I can do SOHCAHTOA actually as well in the red triangle because it's a right triangle. But for practice, let's do law of sines in this case. Okay, you ready? Again, law of sines says you take a side over the sine of the angle. So what's the side given to us? 125 is the side. Which angle is across from that? 16. Now, the side that we want to find in the red triangle is Y, and which angle is across from that? That's going to be 90. So we're going to cross multiply here. You get 125 sine 90 is equal to Y sine 16. We will divide by the sine of 16, and that will give us our value of Y, okay? So I'll go to my calculator. We have a 125 sine 90 close parentheses, divided by the sine of 16. Okay, and that should be about 400. Now, I'm not going to round here, because if I round here, I'm going to cut my value off short. We round at the end. It's generally safe to say we go about 4 decimal places. All right, so I'll say 453.4944, okay? So let's say 453.4944. 4 decimal places should be safe. So now, again, just to recap, what we did is we found side y, which is in the red triangle. It's also in the blue triangle. So what we can do now is use that value and now do the same idea, but now let's go to the blue triangle. Okay? Now, let's go to the blue. Here we go. Take the side. Let's use the side that we now know, the 453.4944. That's going to be over the sine of an angle. Well, in the blue triangle, which angle is across from that side? That's going to be the 7. X is what we're going to have to find, and that's going to be over the sine of, oh no, we have a problem here, because we don't know which angle is across from that, that side. So let's go back, let's zoom in a little bit here, and let's look a little more closely. So this triangle, we need to figure out basically the angle up here, because that's going to be the angle across from the X. So what I'm going to do is I'm going to use some of the information we already know. So we know that this angle here is 16 degrees. Okay, so if I take 180 minus 16, I get 164. Those are supplementary, aren't they? And now in the blue triangle, if I add the 164 and 7, you get 171. Therefore, this angle up here must be 9 degrees to make 180. Does it make sense, everybody, that that 9-degree angle is across from the side X? Because that is what we're going to have to put in as sine of 9. Okay? So I'm going to cross multiply. We have 453.4944 times the sine of 9 is equal to X times the sine of 7. We will divide by the sine of 7. And we go to our calculator. Now here's the good news. The good news is your calculator should already have programmed inside of it that 453 number. We used that one already. Okay, so I'm going to go to my calculator. We're going to type in. Okay, see it's sitting there on the screen right now. So I'm going to take that number. So I'm going to press second answer. Okay. That's the 453 number. I'm going to multiply that times the sine of 9. And I'll divide by the sine of 7. And we want this nearest foot, so it should be about 582 feet is the distance that the ship traveled from A to D. We will practice this more. The next few questions I'll put together on a separate video. We can link them together. But it's, this is a little bit of a process. It's going to take some time. But if you have any questions, let me know, please.